Hi, hello everyone. Thanks for having me tonight. And so I'd like to tell you our story about our React application that we tried to convert to, let's call it API, and how we did it with the help of Fusion.js, a JavaScript framework. So basically, what I will be talking about is quite a generic approach. It's not it's absolutely framework agnostic. So you may use the same approaches with any other framework, but yeah, for some coincidence, we have it exactly with React and Fusion.js. So I would like to start with the definition of API. We all know that API stands for Application Program Interface. And I believe everyone here knows what is API in general. Personally, I like these two quotes about API and what it is. So the API lets you product or service to communicate with other products. That's the important part. And of course, the good API makes it easier to develop your applications. So as I said, API is Application Programming Interface, and I would like to focus on the word interface because no one prohibits us to use this interface as a user interface. So why not to make it a UI, but rather not just I? So basically, API is a contract that allows us to send a request and receive some response. Personally, I decided to break it down into two generic types of interactions. One is a get data, which is very similar to our regular HTTP GET request. Another one is execute action, which is similar to RPC call or HTTP put or HTTP post, whatever else. And so thanks to API, we can execute actions. But what if my action is not just changing some code or some data or whatever else? What if my action requires some UI interaction? Yeah, what if my action consists of multiple sub-actions? How to combine them? A very good example of it is Facebook login to IMDb, for example. So to log into IMDb with Facebook, what we need to do, we need to load basically 2 pages from Facebook. We don't need to load the whole Facebook. Yeah, we don't need the newsfeed or something else. We need just to grant access to IMDb from your Facebook account. And yeah, if you call it flow, yeah, we may think that in our case, in this particular case, the action is to grant access from your Facebook account to IMDb. And why not to call this action? Yeah, and we can think about it as a request. Yeah, so we send a request to Facebook, like, okay, I want to receive some permissions. And there is the response from this request, like, okay, the grant was successful or failed or whatever else. And at some point, we realized that we actually may have several flows like this. Yeah, so they all are similar but completely different. And we may have hundreds of these flows and how to handle all of them. At this point, we define these goals. So we want to create so-called the molecule, the smallest piece of your logic of independently developed component, the one that does exactly one thing, which is single responsible for something easy. And out of these molecules, we want to build another molecules, or we want to build chains of molecules. That's what we call actually flow. So we want to start with some action, then present to user a couple of user interfaces, couple of user interaction screens, and we want to finish somehow this interaction. And the whole chain we would like to call a flow. And yeah. That was our goal, and of course, we had a lot of problems to solve. First of all is the interface. So we had to define something that could be easily pluggable, that's something that we can easily aggregate from smaller parts to bigger parts, something that we can build chains of, and we need to communicate between them, and we need to build these flows. Another problem to solve was state management. For example, if we have in the same flow, we may have several steps, and let's say 2 steps may require the same data, and we don't want to fetch this data multiple times from the backend, of course. So we want to share this data. So how to add the state management, how to share data between flows, between different steps. Another one was final resolution. In sense of HTTP calls, you may think of final resolution as a response. Yeah, so how to send back the response. In HTTP, it's quite easy. You just send a request and you get the response. We have all the transport protocols, etc., etc. But here, how can we say to the consumer that, OK, we are done, our flow is over, and yeah, we want to notify you with the result. And of course, the bundle split, one of the most important actually things, because we want to develop all the flows in the same repository with reusing components, reusing some pieces of code, etc., etc. But once you load one flow, we want to load code related only to this flow. We don't need all other bundles, all other code, all other styles, and etc. And yeah, here's where our exciting journey to solve all these problems starts. So we started with basically code organization. So we want to organize our code in a way that it could be reusable, it could be composable, so we can build chains of our molecules and yeah, just combine it all itself. So we decided that we need some kind of container, whatever it is. I'll talk about it later. As soon as flows may contain several steps, we probably need some router to have routes between them, and of course some presenter. Due to obvious reasons, we decided to add utils, yeah, just to replace the A in this word. So what is the container? Container is the only mandatory piece of this molecule. It's the entry point of the whole piece of logic. It defines the income parameters, it defines the resolution. So basically the income parameters for the request and the response. It also defines the data management, so it fetches data, it stores, it converts, it formats, whatever else is needed. It also controls the flow. Yeah, so if your action consists of several steps, then some parent container should decide which step should be next, how to handle the response from the previous step or request or error or anything else. And of course, this is the only place where we allow side effects. So the rest code should be as pure as possible. The router, it's of course optional. One of the most important things in a router is that it builds sub-routes. Exactly for actions that have some actions or may have some actions, sub-actions, the router builds sub-routes. As soon as we use React, basically router consists of just a switch element from React router. And inside this router, we may also specify this bundle split. We want to specify which components should be lazy loaded, which not, and yeah, how to load them. The presenter, obviously optional, just a visual presentation. For example, in one of the steps may be data fetching, and in this step we want to present just a loader or spinner. Another one may be entering some user credentials or user form. In this case, presenter is just a set of fields where we just put, where user can put some data. And yeah, as I said, we use React router, so sometimes presenter may be responsible for redirects, thanks to redirect from React router component. And finally, utils or utilities. It's optional, it's as pure as possible, and we try to put there as much logic as we can. Because only utils is just a JavaScript code, which is easily unit tested, which doesn't require to use any React or some Jest or some enzyme and other complex systems. So easy to test, so let's put business logic there. So the state management, we had quite a lot of debates on how to share data, how to reuse data. Finally, we decided to use Redux reducers. So basically, two different components, two different crops, they may use the same reducer. So it's enough for the first one to fetch data to be used by the second one. We use higher order components. Just for usability, for code reusability, and it's just easier to use them. And we use React's useState. Thanks to it, we can easily control the state of the crop inside. So if you have multiple steps, you may store the current step or the previous or the next steps exactly in useState hook. So this is the example of a single-step container. Yeah, under single-step container, I mean it's just a crop. It's one piece of logic that does exactly one thing. Yeah, for example, in this case, it will just render something, no matter what it is. So on line 15 and 16, we exactly use high-order components to mix in data into props of the container. And on line 5, we render the router, which in turn renders the presenter on line 9. So yeah, this is the very simplified example. This is the example of multi-step container. So as you see, this container has 3 different steps. Yeah, so this is basically the aggregator of 3 other crops. So it's a confirmation, link, and finalize. And on line 3, we use exactly useState hook to define, okay, this is our current step, which is confirmation by default, and so we need to render the confirmation container, which in turn may render some other views, some other crops, and yeah, it could be as deep as possible or as needed. So the resolver concept. So as I said, we also need to specify the mechanism to allow the consumers to understand that, okay, our flow is over, we are done, and this is the response. This is the result of our operation. And the consumer, I mean, any web application, any website, or whatever else that want to use the flow. So we ended up finally in 2 main approaches. First is post-message. So if you may imagine that the consumer is just a website that mounts the iframe with our application, and once one flow is over, it just posted a message through to the parent window. Yeah, that's how they can communicate. Another one is redirect. That's exactly what you saw on the video with IMDb and Facebook. Yeah, so initially we have the IMDb page, then we redirect to Facebook. We go through the steps, and once all the steps are over, we want to redirect back to IMDb. So that's exactly the final resolution. So this is the response. Yeah, the response was, okay, we want to redirect back because it's success. What is good? There could be anything else. Yeah, you may make a request to backend. You may log something to console. You may alert to a user, whatever. So it's really extensible, and yeah, it scales really good. So the resolver API, basically every container should realize that it will receive the resolver, and each container defines the format of this resolver, so basically the API. But basically, the resolver is just an object which should implement 3 methods. One is resolve. It means that, okay, this action, this particular action that this container should do, it was resolved successfully. Yeah, so that's like a 200 response from HTTP. Another one is reject because of some failure. For example, if the target of the crop was to make a backend call and get the data, and we failed to make a call, we want to reject. Yeah, we want to notify the parent about the error. And notify, sometimes we want to notify about some intermediate results. May be useful, but yeah, notify is optional in our case. So this is just a visualization how it works. So we have several crops, Home, Connect, and Facebook. And Facebook Connect, it consists of 3 different subcrops. Each of subcrop may contain even more. Yeah, so this tree may just grow as much as possible. And this blue circle, it's just like a resolver path. Yeah, so it just goes from one by one, from one crop to another one. And finally, it ended up in Home crop. And Home crop may make a post message or may make a redirect, whatever is needed actually. So this is the concept that we implemented, that we created, and we did it based on the framework. We did it based on Fusion.js. Fusion.js is a JavaScript framework, not yet another one JavaScript framework, fully developed by Uber and supported by Uber. So it's a framework, first of all. It supports server-side rendering out of the box and tons of really useful features. So yeah, just to have an overview of what it is. So the key feature of Fusion is that it's plugin based. I believe this image describes the best what it means. So basically, when request comes, for example, when you want to request an HTML page, it goes through the onion leaves, yeah, where each onion leaf is actually a plugin, so-called plugin. So it goes through plugins one by one in a special order down to the renderer. And renderer actually renders the HTML page and sends response back. And it goes up through the same list of plugins, but in a reverse order. It looks very similar to Express middleware, if someone is familiar to it from Node.js world. So basically, every request goes through all the plugins. The order of these plugins depends. Well, the order of the plugins is the order of registration, or if there are dependencies between plugins, then the framework itself can resolve all these dependencies. So Fusion.js is a universal framework, which means it could run in both in browser and on server. Thanks to these three magic constants, we may define which code we want to run in dev environment, which we want to run in Node.js or in browser. So this is a just brief example. So line 5, for example, will never appear in a production build, or line 9 and 10 will never appear in your browser. Yeah, so it's all controlled by Fusion CLI, by Fusion Builder. That will be on the build stage. It will just get rid of this code, which is not necessary for browser or for Node.js. It's open sourced. The full source is on GitHub, so feel free to check it out. Right now it's monorepo. There is also engineering blog in Uber. There is a Medium articles, and yeah, this is the link to my favorite YouTube video about Fusion. And last but not least, Fusion is production ready. It means that we in Uber already use it actively for all our products. And it has zero configuration, it has bundle split, it has hot model reload, reshaken, it's fully testable with already embedded Enzyme, Jest, and Puppeteer, and of course the list of plugins. So there are tons of already predefined plugins for Styletron, for CSS, for RPC, for gRPC, for GraphQL, for lots of things. At this point, I want to focus on exactly two features that helped us in our crop architecture. The first one is bundle split. So the Fusion React is just yet another plugin. Yeah, so this is just a plugin that we embed, that we register in our Fusion application. And it provides a nice function called split, which accepts just these three arguments. So the loading component, which is the component that we want to present while we are loading the bundle. The error component, if you fail to load the bundle, will show the error component, and the load function itself. Yeah, so basically which component to load. And at this point, the Fusion CLI, Fusion Builder, it will handle everything itself. So it will understand which bundles it should create, how to split the code, how to deduplicate the code, and when which bundle should be loaded. This is really awesome. And the killing feature of the split function that it returns the component itself. So this is the diff. What needs to be done to have the choose container loaded asynchronously in a separate bundle. So it's just 5 lines of code to change and done. So, and yeah, the second feature and the main feature, the main key point of the whole Fusion.js world is plugins. So, as I said, we have plugins for almost everything you need, probably. If not, it's very easy to create your own. You may think of plugins. Yeah, so this is the example of a regular Fusion.js application. So your application actually consists of plugins, of registered plugins. Yeah, so we just register some plugins and middlewares. Middleware is just a simplified plugin. And we register every plugin under some token. So you may think of plugins as a key value map. Yeah, so we have some key, we have some value, and thanks to these keys, thanks to tokens, we may create these dependencies between different plugins. And what is nice, as I said, renderer, in our case it's React, is yet another plugin. So potentially, we may write a plugin for Vue.js, and yeah, at this point we may start creating applications in Vue.js wrapped by Fusion.js. The only requirement is just that this framework should be able to render some code into static markup or static HTML. So plugin is the key point of the whole Fusion.js application. What is plugin? That's the basic backbone of a plugin. Yeah, so it may have dependencies, so each plugin may depend on different other plugins. Each plugin may provide some API, so each plugin may be treated as a service, let's say. Middleware, exactly this function, exactly this onion leaf. So every request to every file in your Fusion application goes through every middleware of all plugins. And inside middleware, you may decide whether you want to, let's say, to cancel the request or to fulfill some data. Or, for example, if it's request to HTML file, you want to add some reset CSS to it, yeah, to header. And the cleanup. It's just useful for unit tests and for clean up some state, some data. This is the example of one of a plugin. So basically, what this plugin does, it just logs the time spent on every request. Yeah, so this plugin depends on another plugin. On line 5, you may see depends on the logger. And this dependency is created exactly by token. This allows us the lazy, make the dependencies lazy. Yeah, we don't really care in which order you register your plugins. Because of dependencies and how you build them, Fusion.js will take the rest and it will create this dependencies tree and will run exactly in the correct order all your plugins. And this plugin has middleware. So on line 7 we get the logger, which will be exactly the object of the logger. It would be an instance of this plugin. And on line 10, we just remember the name of the time when we start the request. And on line 12, we are waiting for next. Wait next, basically, it means that, OK, I want to allow this request to go further to the next plugins, down to the renderer, and then bubble up. Yeah, and once it gets back to the same plugin, we'll get to line 14 and we just log to our dependency, we just log the time spent on the request. So such plugins approach is very flexible and it allows us to do everything that we want and control everything in one place, in one repo. So this is just one application that could act as a server, as a renderer, as whatever else. And at the same time, we may want to run the same code in browser, not just in server. So I believe we are still in the very beginning of a CRUB architecture, and yeah, I still expect a lot of changes and improvements to it. So anyway, if you right now have issues or problems similar to ours, so it's definitely worth of trying it. And yeah, we are also always willing to hear your feedback on it. So yeah, just let us know. And yeah, thank you very much.
Thank you. Question time.
Thanks. Are you using TypeScript in your application?
We are migrating to it. So far, in Fusion.js, we use Flow. But yeah, we are thinking about supporting two of them, of either Flow or TypeScript or both at the same time. But yeah, so far we use Flow.js from Facebook.